Okay, today we're going to go over the Proto TRAK SMX control, and the button right here called mode has one function in life, and that is when you press it, it takes you back out to what I call the front screen or the front page. And what you'll notice over here, you've got a system key. You're going to use that to switch between 2-axis and 3-axis, and also to shut the control off. When you press system, you'll see here it says go to 2-axis. Here it says shut down. You probably won't be using these buttons over here, update, master, or slave, options on or off. The red screen tells you which options are turned on in the control. So I'm going to go over to the 2-axis control right now by pressing this button right here. It says go to 2-axis. Now it's a 2-axis control. And the way you can tell is it's offering you to go back to 3. So we're in good shape there. I'm going to press mode again to get back out to the front page. These arrows up and down, all they control is the green box right here. Sometimes the green box will get too big and you can't see what's behind it. So if you press arrow down, it'll take the green box off of the screen so you can see what's behind it. Press arrow up will put the green box back on. The help key has 2 functions. One is when we press it right now, we'll be in math helps. And as you'll see in a moment when we start programming, the little blue question mark will pop up next to it from time to time. And if you press the help key when you got the blue question mark, it'll give you some additional information to help you program. But right now, if we press help, it'll bring up the math helps. So let's press it. So you got math help A, which says line intersections. Math help B is line arc intersections. Arc intersections is C. D is line arc tangencies. And then E is center points, radius angles. F, polar Cartesian transformation. And G is a good old calculator. The 2 most popular in here, one is under F. We'll go to F right here. And that's math help 28, because it's find the angles and side length of a 90-degree right triangle, which is a common math problem for machinists. So we press 28, draws you a picture of a right triangle. Just input any 2 pieces of information. Let's say we know side A here is 2 inches. We'll type in 2, and then we load it in through the abset key. And let's say that angle G right here is 11 degrees. So we would use data down till we get the G. We'll type in 11 degrees, load that in through the abset key, and there's all the rest of the answers. So you take your answers, write them down on a piece of paper, and then insert them in your program as you need them. So let's come back out to the front page again by pressing mode. The back key just presses, when you press that, it backs you up 1 screen from where you currently were. This is your emergency stop. When you press it, it'll stay in. You have to rotate it so it'll pop back out. This is your go and stop button. When you press go, it releases it to do the commands you told it. You can press stop anytime you want. It's very friendly. You can be in the middle of making an arc and just press stop, and that way you may need to move a clamp or something, and press go and it takes right back off again. Very friendly, stop and start anytime. The override switch here, F and S, stands for feed rate and spindle speed. Right now the F is lit up, so that would be overriding the feed rate. Every time you tap the down button, it'll drop the feed rate down 10%, or if you tap the up button, it'll raise it up 10%. Your override is from 10 to 150%. S is spindle speed, so if you want to slow your RPMs down a little bit or speed them up without going in and making a change on the actual RPM number, you can do that override right here. Just press S. Oh, you know what? This machine doesn't have the, this machine does not have the spindle speed override. So this button here does not work on this particular machine. That was an option that was not purchased. F and C stands for fine and coarse. They control the hand wheels. When you're in F, like it is right now, fine, as you turn your hand wheels for the X and Y axis, it'll move rather slowly. If you press C, which stands for coarse, then it'll move quicker. These are the 2 most common keys that you use, ink set and abset, and this is also where about 98% of all the mistakes are made, because the ink set means incremental information. That means you're referencing your move from where you're currently sitting. The abset key means absolute set. Absolute numbers are referenced back to your 0 point, wherever you have that set up at. And I like to program in absolute, that way I don't get lost as quick. I'm always coming off the 0 point. It's very easy to understand. However, the incremental information can be a faster and quicker way to program at certain times. The other cool thing on a Proto TRAK is you can program it as all absolute or all incremental, or you can blend the 2 together. all in the same program, so it always knows where it's at. Very friendly and easy to program. You have a standard keyboard here. The restore button works kind of like a clear key, so if you're typing in numbers and you type in the wrong number, all you need to do is hit restore and it'll clear that number out so you can put the correct one in. Accessories on and off, that controls your coolant. If you hold it in for 3 seconds, the auto light will come on, so it'll automatically turn the coolant off when it's finished machining. This key here, ink and abs, is only good for your digital readout. So right now, let's go to digital readout. You'll notice on the screen it says select mode. So that means press one of these keys across the bottom. So I'm going to select this one here, DRO, which is digital readout. And it defaults to showing you absolute positioning. If you prefer to look at incremental, press this key here. Now you'll see it change to incremental. I'm going to go back over to absolute. Right now we're working in inches. You can press this key, it changes it to metric. Now we're working in millimeters. So either way you want to run there, I'm going to stay over in inches. And the look button is used to look at your graphical representation of your program. As you start making a program, you can look at it and verify that you put your information in correctly. And again, the mode button only has one function, and that is to bring you back out to the front page right there. That's all it ever does. Let's stay in digital readouts for just a few more moments. This is your X, Y, and Z button. You'll use that to zero out the machine with. You'll notice at the top of the screen, it tells you what's going on. It's in digital readout now. It thinks tool number 1 is in the spindle. We're on the 2-axis side of the control. We're working in inches. You got a few functions here that are pretty handy. One is called jog. When you press jog, it throws up a caution here. If right now, since we're in jog, if I press the X, Y, or Z button and hold it in, it'll rapid that axis. So if I press the X right now, it'll rapid the table. If you want to go the other direction, you press this plus or minus key. You'll notice right here in front of the feed rate number, a little negative will come up. There it is, a little negative 150 now it says. That means the axis will go in the opposite direction. So we'll just stay in the positive here. And I'm all finished with the jog, so I'm going to press return. Power feed works just like the power feed unit that you'll find on a lot of Bridgeport mills. If you just need to mill a keyway, something straight, something easy, you don't even have to make a program. You just press power feed, then you select which axis you want to move. Let's say we're going to move X. Then you tell it how far to go. Let's say the slot's 1 inch long. You always load power feed in through the ink set key because it's always incremental information, meaning you're taking off from where you're currently sitting. You'll notice right there it says X 1 inch. And now when I press go, the machine, X limit violation. Okay, we got a problem here. Let's see what's going on. Seems to be moving just fine. Let's try that again. Power feed, X, 1 inch, incremental information on power feed. Press go. X limit violation, servo error. I wonder if we got the juice turned on or not. Nope, that's it. Yeah, we don't have the electric turned on to the drive motors. Okay, they're going to fix that. So that's the power feed. Do 1 is not used very often, but what it is good for, if you're making, let's say, 5 parts and you need to make a change on just one of them, you can press do 1 and then program it to do a position or a bolt hole, mill, arc, pocket, or profile, and it'll do it for you one time, but then it forgets. It does not become part of the program. So it does let you go in and make an alteration to a job without messing up the program. So that's what do 1 is. It'll do it for you one time. It will not become part of the program. The go-to is an electronic stop. So if you were milling up to a shoulder, let's say, and let's say the shoulder was at X 1 inch, I can press go to, press X 1 inch, load that in through the EBSET key, and now you'll see it says go to X 1 inch. So as I turn my hand wheel, I don't have to try to sneak up on the number because as soon as I get there, it just kicks out. It just stops. The hand wheel's still turning, but the machine stops. So it's like an electronic stop that you can set, and it'll actually kick it out when it gets there. Teach is good for if you've got a part that's already been made and you have to duplicate that part, but you don't have a blueprint. So you can actually take that original part and put it on the table, put some clamps on it, put some stops, and you can go into teach. You can walk the machine, just cranking it by hand, into each hole, and when you're sitting in the center of that hole, I mean, if it's not real critical, you just pick the hole up with a drill bit. If it is a critical hole, you'll need to tram it in with an indicator. But when you get there, then you tell it, that's a position drill move right there. Then you go to your next hole, do it again, do it again. So it's actually recording the numbers and building its own program. So you're teaching it the different moves you want it to make. So you can do drilled holes. You can also do a straight mill. And you get your end mill at the beginning of the slot. You press this key here, mill begin. You get to the end of the slot, press mill end, and then it's taught it that move. Now the teach is a two-step process. You teach it all the moves here in digital readout, but then you'll need to press program and go in and finish it out with tool numbers and feed rates. So that's the teach. Return to absolute zero. Wherever you have your zero set up at, you can press this key right here, and it says ready to begin. Press go when ready. So when I press go, it's going to wrap it back to the 0 point. We still got the X limit violation. We ever get the juice turned on? We're still working on that. All right. And this is tool number. So currently I think tool 1 is in the spindle. If you wanted to change that, you could hit tool number and hit 2, press abset to load it in. So now it thinks tool 2 is in the spindle. But that's a quick little walk through digital readouts.